I'm Anil Kumar. Welcome to my series on review of complex numbers. This is part 1. We will have 13 questions. You can always pause the video, copy these questions, work them out, and then look into my suggestions. In part 2, we'll take up slightly more complicated questions based on complex numbers, and in part 3, we'll have a practice multiple choice test paper on complex numbers. So I'd like you to make a note of these questions. I think you can see first 7 questions here. So you can just pause the video, copy these questions, and then have a look at the rest of them. So these are the other questions up to question number 13. We are going to answer all these questions one by one in this particular video. The last question here is find square root of 3 plus 4i. Perfect. So now let's begin with the very first question. As I explain you the answers, I'll also review the basic concepts which we have learned about complex numbers. I hope that's a good idea, right? So we'll begin with question number 1 itself, which is find zeros of x squared plus 4. Now, as you have learned, x squared plus 4 will not have a real zero, right? And that gives rise to the set of complex number. So if I write x squared plus 4 equals to 0, I get x squared equals to minus 4. Now, in set of real numbers, square of a number is always positive. And that gives us an idea that we should extend our number system to something which could take care of this, right? Since x squared is minus 4, we should have a solution to that. So for that, we have a letter I square, and that is equal to minus 1. So this is the complex part of our complex number system. So now, x squared equals to minus 4, we can write x as square root of minus 4. Whenever you do square root, you have to take both positive and negative. These are the conjugates, right? Now, when I say x squared is, I squared is minus 1, it really means that I is equal to square root of minus 1, correct? So that gives you the solution as x equals to plus minus 2i. So this is a pure imaginary number, plus minus 2i, correct? If you square plus minus 2i, you will get plus 4, right? So that's the whole idea. So if you square this number, you will get the roots of this particular equation. So I hope that helps. So what you get here as a solution is x equals to plus minus 2i. So if you substitute 2i here plus or minus, you will get 0 of this particular equation, right? So I hope you understand the basic concept and the need for our complex number system. Next question here is, if z equals to 2 minus 7i, write the conjugate of z. Now, conjugate of z will be written in general, z with a bar on the top. And when we are talking about conjugate, the sign changes for the complex part. So, 2 plus 7i becomes the conjugate of z, right? Question number 3. 1 plus 2i plus 4 minus 3i, conjugate of their sum, right? Now here, what we can do is, we can first do the addition part, right? So we have, within this conjugate, we can combine the real parts and the complex parts. So we have 1 plus 4 plus 2i minus 3i, correct? So that gives you 5 minus I conjugate, right? So conjugate of this is 5 plus I. So that is how you could find solution of such a question. Now remember, Sum of the conjugate of two complex numbers is also equal to sum of their conjugates, right? So you could also do it alternatively, that is to say, we could also write this as 1 plus 2i conjugate plus 4 minus 3i conjugate. Let me do and show you this rule, right? So in this case, conjugate of 1 plus 2i will be 1 minus 2i, and conjugate of 4 minus 3i will be 4 plus 3i. Now when you add them, 1 plus 4 is 5, and minus 2i plus 3i is I. So you get the same result, right? So this is a very important rule, that sum of conjugates is conjugate sums, right? So either way you could find it. Okay. Now the next problem is kind of straightforward. We'll just add the real parts and subtract the real and the complex parts. So that is how we subtract the complex numbers. So we can open the bracket. We get 5 plus 3i minus 4 plus 5i. And 5 minus 4 is 1. 3i plus 5i is 8. So 1 plus 8i is our answer. Perfect. So I hope till now there is no difficulty. Now let's look into powers of I. Now we know I square is minus 1. So what is going to be I cube? What is going to be I to the power of 4? And then I to the power of 5. That is what we have to work out. Now let us evaluate powers of I. So let's find a general rule for finding powers of I to the power of n, and then we'll write down the answer for I to the power of 5 and I to the power of 99. It is easy to work in this fashion. So this is kind of an easy way of learning. So let us say here we have I. Let's start with 1. So let's say on the real axis we have 1. On the imaginary axis we have I. Then on this side we'll have minus 1, and here we get minus I, correct? So when you're working with powers of I, so here we have I to the power of 1, correct? So when I multiply, so this is like I to the power of 1. So when I multiply by another I get I square, which is minus 1. And then when I multiply, I get I cube, which is minus I. And then I get I to the power of 4, which is 1, right? And then I get I to the power of 5, which is I itself. And this cycle repeats. Do you see that? So from this particular cycle, we can easily find the powers of I. Does it make sense to you? Right? So that is how we could do it. So from here, we can write this. This is like 4 plus 1, right? I to the power of 4 is 1. So we know I square is minus 1 and I to the power of 4 is just 1. Is it okay? So that helps us to figure out the answer. Or you can get into this cycle, correct? Multiples of 4. So I to the power of 5, as we have seen here, is equals to I. And as far as I to the power of 99 is concerned, it will end up here, right? So that will be 99. Here, 4 multiple is 100, right? 1 less than 100 is 99. So we'll get minus I as our answer. Does it make sense to you? So what we need to do here, we need to divide the number. We can divide 99 by 4. Right? So we get 4 times 2 as 8, 19. 4 times 4 as 16. Remainder is 3. So remainder 3 means 1, 2, 3. So we get our answer as minus I. Do you see that part? So we also say mod 4. So that is another way of doing it. This is by division. So I hope this step is absolutely clear. So using this method, you can easily find powers of I, correct? So if I write I to the power of 50, for example, this is same as, multiple of 4 will be 48, right? This is same as I square, which will be minus 1, correct? So that is how you can easily get your answers. So I hope this concept is clear. Let's move on to question number 7. Now let's see how to multiply complex numbers. Question number 7. 2 plus 3i times 3 minus 2i. So to multiply, we need to multiply just as we do in polynomials. First with 2, we'll multiply both the numbers, 3n minus 2i, and then we'll do the same with 3i. Okay? So that is the process. So when you multiply by 2, you get 2 times 3. Let me write this as 2 times 3, and then 2 times, so minus sign, 2 times 2i plus 3i times 3 minus 3i times 2i, correct? 2 times 3 is 6, 2 times 2 is 4, I. Now here we get 3 times 3 as 9i, and 3 times 2 as 6, and then we get I square. Now I square is minus 1, right? Remember, I square is minus 1. So that becomes plus 6. So we could write this as 6 minus 4i. We could combine these two, right? And here this becomes plus 6 since I square is minus 1. And now we can combine the like terms. So the like terms are real and the imaginary parts. 6 plus 6 is 12. And minus 4i plus 9i is 5i. So that is how you could actually multiply the complex numbers. So we get our result as 12 plus 5i. Correct? So that is how you do it. Now let's do this part, question number 8, which is if z equals to 3 minus 2i, find the magnitude of z, right? So magnitude of z will be written as this. So it is a square plus b square square root. So magnitude of z is equal to square root of 3 square plus 2 square, which is square root of 9 plus 4, which is square root of 13. So in general, magnitude of any complex number, a plus bi, is equal to square root of a square plus b square. Correct? So that is the general rule. Let's continue to question number 9. Here, if z equals to a plus bi, find the product of z and its conjugate, right? So we want to find product of z and its conjugate. So that is the conjugate. So we can write this as a plus bi times a minus bi. So that becomes the conjugate, correct? So it is like difference of squares, right? So what do you get here as a square minus bi whole square. Now remember, I square is minus 1. So what you get here is a square minus b square I square. Now since I square is negative, we get a square plus b square. So the product of the complex number with its conjugate in standard form, if given, like a plus bi, will be a square plus b square. So that's an important formula to remember, right? Now here we have complex number z equals to a plus bi. We need to find what is z square. So let's find square of a plus bi, right? So we have a plus bi whole square. You can multiply them. So get a square plus 2 times a times bi plus bi whole square. So we get a square plus 2abi. Now this is b square I square. I square is negative 1, right? So we get a square minus b square plus 2abi as our result. So the square of a complex number could be written as a square plus 2abi minus b square, or rearranged in this particular fashion. So I hope that is clear, right? So we are almost at the end now. Here is question number 11. Now we need to find reciprocal of a plus bi. Let me write in standard form. Okay. So reciprocal means what? Reciprocal means 1 over a plus bi. Does it make sense? So that is the reciprocal. This is what we have to find. Now, we cannot write bi here in the denominator. That is not a standard form. To write it in standard form, we multiply and divide by its conjugate, right? So what we do here is we multiply and divide by a minus bi. Correct? So once you do that, you get a minus bi on the top, and the denominator becomes a square minus b square, so which is a square minus bi whole square, right? So which I could write as a minus bi divided by a square plus b square, right? Since I square is negative 1, we have seen in a couple of videos. So this now could be written as a over a square plus b square. That becomes the real part, and the imaginary part will be b over a square plus b square with negative I. Do you see that? So that becomes a reciprocal of any complex number in general. Correct? So for you, let me write a question here. Let me write question 11b. Find reciprocal of let's say z equals to 2 minus 3i. Is that okay? So basically the reciprocal will be 2 over 2 square plus 3 square minus, now since this is already negative, you may have to see that. So it will become positive because you have to multiply by the conjugate. Do you see that? So it will become plus 3 over 2 square plus 3 square. So let this be your exercise. Is it okay? So that is for you to do. Now let's take up the next question, which is question number 12. If z equals to 2 plus 3i and w equals to 3 plus 5i, find z over w. So we need to find quotient of the two complex number, right? So that is what we need to find. That is 2 plus 3i divided by 3 plus 5i. Now we want to write this also in standard form. So that is always assumed. So always in standard form. Avoid writing complex number in the denominator. So to get it in complex standard form, we'll rationalize kind of, multiply and divide by its conjugate. So that is what we will do, right? So what do we get? Let me write here. 2 times 3, which is 6, 2 times minus 5 minus 10i, multiplying by 3i gives me plus 9i and minus 15i squared. The denominator here will be a square minus b square, which is 9 minus 5i whole square. Now purposely I'm not doing it in one step. I'm trying to write I square and then change the sign. It helps, right? Okay, so combine the like terms. This is like plus 15, right? Let's rewrite. We get 6 minus 10i plus 9i plus 15. So that becomes a real part. And the denominator is also real, 9 plus 25, correct? Now, you can write 6 plus 15 is 21, so we get 21 over 9 plus 25, which is 34. So that becomes the real part, and the complex part will be minus I, that is 1 over, we can write 1 over or I over 34. Is that clear? So that becomes the answer, right? So we could write that z over w is equal to 21 over 34 minus I over 34. Perfect. Here is the last question, which is kind of tricky. Now we need to find square root of 3 plus 4i. How do we find square root of a complex number? Okay, so basically we need to find square root of 3 plus 4i. let it be equal to a plus bi. So that becomes a standard form, right? So we could square both sides. So at this stage, let us square both sides. In that case, you get 3 plus 4i equals to a plus bi whole square. So we can write 3 plus 4i as equal to a square plus 2abi plus bi square, which is minus b square. Correct? Now, from here you can see we can compare the real and complex part, right? So equate real and complex parts. So what we get is that 3, which is the real part, is equal to a square minus b square, right? And 4, that is 4i, is equal to 2ab. Perfect. So that is how we could actually equate them. So we know difference of a square and b square is 3 and 2ab is 4. Now that should help us to solve the equation further. So from here we can see what a is, right? So this implies that a is equal to 2 over b, correct? Dividing by 2b, we get a is 2 over b. So now we know that, let's write here. We know that 3 is a square minus b square. A is 2 over b. So 3 is 2 over b whole square minus b square. So that gives us 3 as 4 over b square minus b square. To solve this, we'll just multiply by b square. So we get 3b square equals to 4 minus b to the power of 4. Now bringing all the terms together will give us b to the power of 4, bring them to the left, minus 3b square minus 4 equals to 0. And we could factor this, right? So if you factor this 3b is positive, sorry. We bring these two terms to the left. If you factor this, you get b square, that should be plus 4 and minus 1, right? So b square plus 4 times b square minus 1 equals to 0. Now a and b are real numbers, okay? So in this, a and b are real numbers. So that means that is not a solution, but this gives you two solutions. So we get b as equal to plus 1 or b equals to minus 1. Now since a is equal to 2 over b, we get a equals to 2 or we get a equals to minus 2. Correct? So we get a solution here, which is when a is plus 1, b is plus 1, a is 2. So we get the form is a plus bi, right? So we are looking for a solution in the form a plus bi, right? So a is 2 when b is plus 1, so plus I, or we get minus 2 minus I. So I could always write this as plus minus 2 plus I as my answer, correct? So that becomes my solution. So square root of this is, let me rewrite here, square root of 3 plus 4i is equal to plus minus 2 plus I. So there will be two solutions to this, and that is 2 plus I or minus 2 minus I, correct? So that is how you find it. Now in part 2, we will see shortcut methods of finding answers for such questions, which are kind of difficult at times. Shortcut methods to do many questions which we have done here. And then in part 3, we are going to take up some multiple choice questions which will help you to perform well in any test on complex numbers. I hope that helps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.